Right, you're all familiar with the constant acceleration formulae, and in particular, this one here, s equals ut plus a half at squared. You've been taught it, it's been repeated again and again, and it's true, but only if you start from the origin. If you start from somewhere else, that isn't true. Let's go back to basics here and say, we know what the acceleration is. So the acceleration is dv by dt, and I know the acceleration is a. That's my starting position. If my acceleration is a, I'm saying that my acceleration is a constant. If dv by dt equals a, then I can work out what v is. So let's do that first. V is the integral of a dt. Well, the integral of a dt is a t plus c. So it's telling me that v equals a t plus c. And you might recognize that. We always say that c is u. V equals at plus c. Well, that's true if when t equals 0, v equals c. So let velocity at time 0 equal u. So we've got v equals u plus at. That one is true. So that's a formula that is true. If we start off with velocity of u, then v after time t is given by u plus at. V, though, is ds by dt. V is the rate of change of position with time. So ds by dt equals v equals u plus at. We want to know what s is. So s is the integral of v dt. The displacement is the integral of the velocity with respect to time, which equals the integral of u plus at dt, which equals, well, let's integrate u plus at dt. Ut plus, that's going to be a t squared, so that has to be a half, plus a constant. I won't use c because I used it up there, so I'll just use k. So the correct value of s is s equals ut plus a half at squared plus k. And when t equals 0, s equals 0 plus k. So k is the displacement from the origin at t equals 0. So this equation up here is true, but only if I start from the origin. If I start from anywhere else, it becomes this. S equals ut plus a half at squared plus k. It simply requires that I know where I start from. And if I know where I start from, the correct equation is not this one. The correct equation is S equals ut plus a half at squared plus a value. Now that's really been, I suppose, skipped over in the past, but ignored. They've just told you to use this. And they've assumed that you're just starting from the origin all the time. So they introduce vectors here. They've changed what they're doing, and they're saying, now we are not starting from the origin, so we're giving you an equation which actually takes into account our starting position. But let's now work with vectors. Once we've got that bit up, that idea sorted out, we can now start dealing with what it is they're trying to teach us. They tell us that that we're going to use a vector for position. So our vector r will be our position, and it will be our initial position plus vt, where v is a constant. So if the velocity is constant, then our position will be r0 plus constant times time. What that means is, let's say I start from this point here. If I have a vector for my direction in this direction, then I will move from this point to, the vector here is v, sorry. So I move from this point to this point plus v times t in time t. Give some numbers for that, make it much clearer. If we start from 3, 7, so r0, our starting position, is 3, 7. And my velocity is constant. And my velocity is 2 minus 1. Then in a time of 4 seconds, r, now I'd like to use this notation, r at time 4 is r0 plus 4v. The velocity is constant. If I know where I start from, and I travel for 4 seconds, then I move to the point r0, the place I started from, plus 4 times the velocity. So in this case, equals r0 given, 3, 7, plus 4 times v is given, 2 minus 1, and just work out the answer. 3 plus 8. 7 minus 4. So I move from 3, 7 to 11, 3 in 4 seconds if the velocity is constant. You can then expect follow-on questions like find the time when we're due east of the origin, which really means find the time when the y value is 0. So r of t equals r0, 3, 7, plus t times v is 2 minus 1. This is where v is constant, remember? And they want me to find the time when the y value is 0. So when due east, seven minus t equals 0. That implies t equals 7. And our units there, I think, were seconds. Yeah, seconds. Okay, the next one to look at constant acceleration again. So rather like we did down here. So with constant acceleration, if we're in 2 dimensions, we've got A, the vector, is A1 and A2. That's a constant. A1's a constant, A2's a constant, but because we're in 2 dimensions, A is made up of 2 vectors, a vector in this direction and a vector in this direction. Well, if I integrate this, because A equals dv by dt, that implies v equals the integral of A dt. Let's integrate that. What do I get? V equals A1, integrate this one, times t plus, I'll say k1, integrate the second vector, A2 t plus k2. So the velocity vector is A1t plus k1 in the x direction and A2t plus k2 in the y direction. K1, K2, they're just the initial velocity. So at t equals 0, v of 0 equals a1 times 0 plus k1, a2 times 0 plus k2, which equals k1 and k2. Then we say, well, in that case, let's define the initial velocity. Let v of 0 equal u, and then u equals k1, k2. And now we get the familiar v equals u, the initial velocity, plus a t. I'm underlining all of these ones here to indicate they're vectors. V is a vector, it's in 2 dimensions, it's made up of v1 and v2. U is a vector, it's in 2 dimensions, it's made up of u1 and u2, which we found to be k1 and k2 just now. And A is a vector, it's in 2 dimensions, a1 and a2. Okay, now we're going to be given some numbers and asked to solve something, aren't we? That's the way it always works. What numbers are we being asked to solve here? So we can expect a problem that involves v, u, a, and t. V of 0 equals 2, 1. We'll call that u. That's our normal, isn't it? Velocity at time 0 is u. The acceleration is 2 minus 1. Find the speed and bearing at t equals 5. Okay, it's a constant acceleration. Bearing. Now, unless we're told otherwise, the normal rules are that's north, that's east, and it corresponds to x and y. X goes this way, y goes that way. So find the speed and bearing at t equals 5. Okay, our equation is v equals u plus at. Put our values in. V equals u, 2, 1, plus a, 2, negative 1, t is 5, times 5. I'll answer straight away here. I suppose 2 plus 2 times 5, that's 12. 1 plus negative 1 times 5. So 1 minus 5, minus 4. My velocity then is 12 minus 4. What does that look like as a vector? That means I'm going along in this direction, 12, and downwards, 4. I've been asked to find the speed and the bearing. They have not asked me to find the velocity. I found the velocity, but they haven't asked for the velocity, they've asked for the speed. So the speed is this length here. There's my speed. Let's use my normal rules for working out that length there. It's a right-angled triangle. It's Pythagoras. So I've got, I'll call this x. X squared equals 12 squared plus 4 squared equals 144 plus 16 equals 160. So x equals the square root of 160. That's the square root of 16 times 10, which is 4 root 10. I much prefer that answer to the answer they're probably going to want me to give them, because 4 root 10 is definitely exact. But I'll pick up my calculator and work out the answer. 4 times root 10 equals 4 root 10, and that's 12.649. Speed equals 12.649 ... round it to something reasonable. The exam will usually say 3 significant figures unless told to do otherwise. 12.6, because it is so close to 12.65, I think I will actually say 12.65, because nothing in the question said we had any estimates being made. I didn't use G equals 9.8, so 12.65 seems a reasonable estimate to give to 2 decimal places. Obviously, if the model is not that good, then that's more accurate than they want. But I've not been told where this model comes from. Okay, that's the first bit done. I found the speed. Can I find the bearing? Well, I know the bearing is the angle from north clockwise. So look at this image here. I've got north is in this direction. The bearing is this much, 90 degrees, plus this much. I need to know what this angle here is. For the purposes of working out what alpha is, I don't care that this is negative. All I care about is the size of alpha. So alpha, I've got a 4 and I've got 12. That's the opposite and the adjacent. So for bearing, alpha equals tan to the minus 1 or 12ths equals tan to the minus 1, 1/3 equals my calculator. Firstly, find out the, so make sure that I know what I'm in. Am I in degrees or in radians? Bearings will be in degrees. So I'll just do a quick check. Put it in degrees. Always check which one you're in. I want shift tan 1 divided by 3, close the bracket, equals 18.43 ... My bearing equals, I've got 90 degrees plus 18.43 equals, and with the bearing, well, you just want me to give it as the number of degrees, 108 degrees. 90 plus 18.43, 108 degrees. And there's a question of the type you might expect to get. Take care with part B and part C. See if you can solve that. I'll with you in a bit. So hopefully you found the first bit, part A. V at time 4 is V0 plus A times T, which is -1, 2 plus 4 times 2, 2 is 7, 10. The second bit there is trickier. Find position R of 4. So we need to begin with, we know what A is. We know in general what V is. V of T is U plus AT. We know what U is. -1, 2. We know what A is. That's 2, 2. And we know what T is. We're okay on that bit. R of T, though, need to integrate V. Equals, well, let's integrate that. That's U, so it's UT, plus, that's AT, so it becomes AT squared, and that needs to be a half, plus some constant. What's the constant? We need to know what happens at 0. So R of 0 equals 0 plus 0 plus C But they told me what R of 0 was. It was this one here, 5, 1. C equals 5, 1. So my equation for R of t is R of t equals ut plus a half at squared plus 5, 1. I want to find the position vector at 4. R of 4 is 4 times u. What was u? Minus 1, 2. Plus a half times a. A is 2, 2. So a half times a is 1, 1. Times t squared, 16. Plus 5, 1. Equals minus 4, 8. Plus 16 and 16. Plus 5 plus 1. Which equals minus 4 plus 21 is 17. 24 plus 1 is 25. And finally then, so we know then the position R of 4 is 1725. That's much trickier. Then part C, find the distance from starting position. So R0 was the starting position, and that was 5, 1. I am now at R4 is 1725. And I've gone 12 in that direction. We've got 12 in that direction. And 24 in that direction. The distance is that distance there, x. Again, it's Pythagoras. X squared equals 24 squared plus 12 squared. X equals the square root of 24 squared plus 12 squared equals 12 root 5 equals 26.8. It was meters. 26.8 meters. Okay. I'd recommend doing exercise 8A, page 162 in Edexcel's A-level Maths, Stats and Mechanics Year 2.